This is part 7 of the series, An Introduction to the Derivative, and we're going to look at the derivatives of the trigonometric functions in this session first. Now this is just a presentation for reference purposes. If you would like to look at the actual derivations of the 6 trigonometric functions, they are all presented in separate videos in a separate series. And I would strongly advise you do that because all 6 trigonometric derivatives aren't used all the time, and it's difficult to keep things in memory that you don't use. And if you go through those proofs, you'll be able to generate the derivatives and reproduce them for whatever purpose you need without having to commit them to memory. It may take a little bit longer, but at least you will have a method of working out problems that otherwise you'd be stuck working out. So let's begin, and we're going to look at the derivative of the sine function first. So the derivative with respect to x of sine x is cosine of x. Now this one's pretty straightforward. If we think about what the derivative is, being the slope of the tangent line of the function at any given point, we can see visually how cosine would be the derivative of sine. So let's just quickly bring up the graphs of sine and cosine, and you can see this graph is the graph of sine on 0 to 2 pi, and this graph is the graph of cosine. Now if we take a look at this function, the graph of the function sine, the slope of the tangent line here is 1. And so we see that cosine at 0 is 1. As this function increases, we can see that the slope of the tangent line would be flattening to the point where the tangent line is horizontal right here at pi over 2. And at pi over 2 we can see that cosine is decreasing and it reaches 0 at pi over 2. Again, following the slope of the tangent line of this sine function. As sine continues, the slope of the tangent line is negative, and in fact cosine goes negative, and the slope of the tangent line along sine is continuing to be more negative until it approaches here, which it's actually 0. So you can see that cosine is bottoming out here, and then as sine continues, it's still negative, but it's flattening out, so getting more and more positive, if you will, and so cosine is coming up, where again the tangent line of sine is horizontal, which gives it a 0 slope, and so cosine is 0 at that point, and then it continues to get more and more positive, and cosine continues to increase to where the slope of the tangent line at 2 pi of sine is 1, cosine is 1. So there you can see a graphical representation of the derivative of sine being cosine. So now let's look at the derivative of cosine. Derivative with respect to x of cosine of x equals negative sine x. So to look at this one graphically, let's bring up the derivative, the negative sine and cosine functions. So this white one, or this light colored one, is negative sine, and this one is cosine. So again, looking at the derivative as the slope of the tangent line, you can see that at the beginning, at 0, here at 0, the slope of the tangent line of cosine is 0. And in fact, negative sine is 0 at that point. And we can see the slope of the tangent line is getting more and more negative till we get to this point. And then it's starting to increase down here. and we can see that it's negative and then increasing. Still negative, but now increasing. And the slope of the tangent line is again 0 at pi, and negative sign is 0 at pi. And again, it continues to increase until this point, and then it starts to decrease again, and we can see that it's starting to decrease. The slope of the tangent line here is decreasing until it reaches 0 one last time at 2 pi, and there we have negative sign is at 0 at 2 pi. So we can see again graphically that the derivative of cosine, the slope of the tangent line of cosine, is given by the function negative sign. Now the rest of the derivative functions will be given here for reference. So the derivative with respect to x of tangent of x is secant squared x. The derivative with respect to x of cosecant x is negative cosecant x cotan x. The derivative with respect to x of secant x is secant x tan x. And lastly, the derivative with respect to x of cotan x is negative cosecant squared x. Now, a couple of important observations that you'll want to make. Notice how the derivatives of all the cofunctions, the derivative of sine is cosine, the derivative of cosine is negative sine. The derivative of all the cofunctions are negative. The derivative of cosecant is negative. The derivative of cotan is negative. The derivative of the primary functions, sine, tangent, and secant, are all positive. And notice that the derivatives of cosecant and secant are all the cofunctions of each other. So the derivative of secant is secant tan. Cosecant is negative cosecant cotan. Same thing with sine and cosine. Derivative of sine is cosine. Cosine is negative sine. And the derivative of cotangent and tangent, derivative of tangent is secant squared. And the derivative of cotangent is negative cosecant. So secant, cosecant. So they're all cofunctions, and the derivatives of the cofunctions are negatives of each other. Again, it would be very helpful for you to look at the proofs of these derivatives so that in case you forget these, you'll be able to reproduce them manually on a test or for a practical application if you need be and don't have a computer algebra system at your disposal. So now we're going to move on to implicit differentiation.